as well as a working program that follows style guide and other guidelines, one of the things you need to do is testing and evidence of testing. So let's just have a quick look at the progression from achieved to merit to excellence. So for achieved, you need to show us you did test your program. It might not be particularly comprehensive testing, and you might not have been testing for invalid inputs correctly, but you have at least tested your program once. We've got evidence of that. It's a big step up to merit though, because for merit you have to do an ongoing testing. So we have to see that you tested versions of your program as you developed it. So you didn't just like test right at the end, which is like fair enough, because when you write a program, you obviously test as you go along. You don't just write the whole thing and then hit the run button and hope that it all works. As you've made changes, you keep testing. So we'll look in a minute at what the evidence could look like. And then lastly, for excellence, you need to have been very mindful of all the different possible cases, like obviously the valid inputs, but you need to think about the invalid inputs or unexpected, or just anything that could be entered into your program that might cause it to have a problem, and particularly the boundary ones, although boundary comes up in merit as well. And that's the ones where you've got like out by 1 errors. So you might have something that's supposed to count to 10 but actually it counts to 11, or you might have something where an input is expected to be between 1 and 100 and it accepts 99 but does not expect 100 when it's supposed to. Those are kind of the boundary issues. The other thing you need to do is get someone else to test your program throughout the development process. Now that doesn't mean necessarily every day, but it would mean that like 2 or 3 times you've got someone who isn't an expert in the subject who has given it a bit of a go-over, run through it. The analogy in the real world is that testers need to be non-expert. They need to be the actual users of the program. And one of the problems is, as the programmer yourself, you tend to avoid the errors that other people might make when they use your program. So this is just trying to get those errors to come out. So let's have a look at what this might look like. This is an example that I wrote. This was for a bowling program. Scoring a game of bowling is really complex. It's really unpleasant. You'd just be glad that I didn't make you do this as an activity in class. What I've done here, I'll just quickly scroll through it and then I'll scroll back up to here. So I've taken a screenshot of some testing that I did. I typed in some values and I got some output. And I've said what I was testing for. I was testing that these values went into this array. And I've said that I was testing that this structure was correct. So I've got a list of lists and they're all in pairs along the bottom. That's exactly what I wanted. Exactly 10. Yep, there's 10 there. And I also wanted it to do, if I entered a 10 here, it said you got a strike, which it did. Now, I kind of deliberately made an error here. I entered a 10 for ball 2, and that isn't a strike. The second ball in the frame can't be a strike, so that's an error. So I've kind of highlighted that in red just to do that. So that's me having logged my first bit of testing. Then I updated my program, and I've said what I wanted to test. I wanted to test that there were 10 if I got a strike. And if I entered a strike for the second ball, I did not get the 3 balls thing. And that happened correctly. See, I've got the 10, 1, 2. I've got 3 in that one because I got a strike, and then you get an extra 1. But it didn't get it for the ball 2 here. So that was correct. So I've again logged that I've tested that. This is a pretty common one as well. I didn't add any functionality. I just refactored my program to make it more robust. I'll put some functions in, and probably a thing that you're going to do as well. I stuffed it up first time. I had all these nuns appear because I forgot to do that. So I highlighted that in red. It didn't do the frames thing correctly. And then I fixed it and I got everything that I wanted and the output was as expected. And then for this last version, I actually wanted to check. I'd added something to the program, work out the total score. I worked out what the expected output would be, 48. And then I ran it and I got 48. Yay, go me. And then this is an interesting one, this last one. What I've done is I've written a actual function called test. So rather than having to type in all of these numbers every single time to test that this works, I said, okay, here's the set of values. I'll type it in once, and then I'll call the function with those values and check that I get 48. And then I run it, and it said 48. And I also did another one just to double check that. And I could put some boundary values in there and invalid and all the rest of it, and check that I get these the values that I'd want down here. So this is the closest to what actually happens in the real world, where people write programs to test their own program. You'll hear of unit testing. Unit testing is where you write code that tests your code in exactly this way. And then scrolling down, I've got my versions 1, 2, 3, 4, 5, so it's easy for me to check the check that I've done each updated version. You'll notice I've put screenshots in here just to preserve the formatting. The color coding of the different elements makes it 100 times more readable rather than pasting the code directly in there. Now, of course, that's going to be a problem when your program becomes long. So if you could just like do it in 2 screenshots or something, that would be really, really appreciated. And just going back up to this bit here where I've talked about what I've done, just to see that I haven't missed anything. Here we go. So yeah, this example is very thorough. I tested more often probably than you would in doing yours, but you know, better more thorough than not thorough enough. I didn't do the invalid entry yet. I was going to add that later in the program, so that I'll do that, and then I'd have that in place, and I'd test those, and that'd be merit and excellent stuff there. Testing that someone else has used the program. This actually needs to be authentic. You can't just say, oh yeah, and my made-up friend tested it and it worked fine. This is excellence, and it needs to be a real person, and you need to actually watch them, and you need to hopefully learn from the mistakes they make. Maybe you are not communicating properly in your program. You need to rewrite the bits that give information to the user or something like that. And don't make it the person sitting next to you in class, because they're writing the same problem, same program. They know what's going on as well. Try and find someone who isn't actually writing the program. It could be like in your tutor group, tutor time, or a parent at home or something like that. And just get them to run through the program. And it should be multiple times. It doesn't need to be like 10 times, but 2 or 3 would be really good. Now, this isn't the only way you can present the evidence, of course. I've seen people do things like these tables here, where you do a test plan, and you'd say, this is the input that I entered, this was the expected output, this was the actual output. So, you know, you expected 48 to come out, and actually 48 came out, so that was great. And the explanation of the test would be what you were testing. Only problem is these tables can get really jammed with information, but it is a nicely organized way to do it if you want to do that way. And also then you could do a separate table. This is my testing for valid values, then this is the testing I did for invalid values, and this is the testing I did for boundary values. And then up here you could do a log and say, on this day I did my valid values the first 3 tests, and I did the boundary values the first test, and the status would be they passed successfully or whatever. So if that seems more organized to you and something that you can keep on top of, that'd be great. Last thing I'm going to show you is this. What is what my folder looked like at the end of doing this particular exercise. It was no big deal to save some versions. Do a right click, do a file save as, version 1, version 2, version 3, etc. Save them all in here. And then I've just taken screenshots. So that's the screenshot of one piece of testing, and I saved it with the version number. And yeah, it meant that actually I was able to not constantly have to go back to my document, but I was able to do the testing, have the record of it, and then do the update of the document in one big hit a little bit later. That may be useful to you, so long as you don't leave it all until the end, because that's a recipe for not actually doing it properly when you get to it.